Okay, hello everyone in a new video. In this one we are going to solve an exercise related to optics in the chapters of lenses and formation of images. This exercise was a previous one in the Brevet exams in 2007, first session, first exercise. The title of this exercise is Determination of the focal length of a converging lens. The aim of this exercise is to determine by geometrical construction the focal length f of a lens L. The figure below represent they mentioned the figure. So now I can use the figure. In a real scale, a luminous object AB and its virtual image A prime B prime given by L and the optical axis X prime X of L. Okay, so here in the figure we have that the direction of propagation of light is from left to right. The optical axis in the same direction. We have the object AB. We don't have the lens, however we have the image A prime B prime of the object AB formed by the lens. And the figure is given using a real scale, so 1 centimeter along the axis and 1 centimeter along the y-axis. So number 1, nature of L. Okay, the lens L is a converging. Why? Okay, usually we determine the nature of the lens from its role, and the role is determined from the properties of the image. Notice that here the image A prime B prime is pointing upward. And the object AB is pointing upward. So both the image and the object have the same direction, which means that the image is erect with respect to the object AB, which means that the image is virtual. Moreover, the image A prime B prime consists of 1, 2, 3, 4 divisions, while the object AB consists of 2 divisions, which means that the image is virtual and larger in size. So let's write this down. Since the image A prime B prime is virtual and larger in size, so what does this mean? From these properties we can deduce that the lens L is playing the role of a magnifier. Then L plays the role of a magnifier and we know that only converging lens can play the role of a magnifier, which means it is a converging lens. Okay, so this is it for part 1. Now part 2, position of L. Okay, part A. They are telling me the optical center O of L is the intersection of the line BB prime with the optical axis X prime XY. Okay, we know that an incident ray issued from B passing through the optical center emerges going to B prime or as if coming from B prime. Therefore, the points B, B prime and O belong to the same straight line. For this reason, the intersection of the line BB prime with the optical axis is the optical center. They are telling me why, so let's justify it. So if we join B and B prime, the intersection of BB prime with the optical axis is the optical center. Why? Because an incident ray issued from B passing through the optical center emerges without deviation. So this is it for part A. Now in part B they are telling me redraw on a graph paper with a real scale. The above figure represents the lens L on this figure. So we need to redraw. The direction of propagation of light is given from left to right. So always whenever we need to redraw the figure, we always start by drawing the optical axis. Okay, this is the optical axis at the middle. Do it better. Okay, having the same direction of that of propagation of light. This is x prime and this is x. Now here we have the point A prime. Let me do it here. This is the point A prime. And the point B prime located 1, 2, 3, 4 divisions above the point A prime. So we have 1, 2, 3, 4. This is the point B prime. A hat is found on B prime. Now let's join A prime, B prime, trace the image. The image is dotted because it's virtual. Now the point A is located 1, 2, 3 divisions behind A prime. So 1, 2, 3, this is the point A. Moreover, we have the point B located 1 to 2 divisions above the point B, and a hat is found on B. Now let's trace the object. Okay, the scale is given by a real scale. So 1 centimeter along the x-axis and 1 centimeter along the y-axis. Now in the same part they are telling me represent the lens L. In order to represent the lens L, we need to determine the position of the optical center, and this is done by joining the line BB prime. Okay, so let's join B prime B, and we join them dotted because the image is virtual. Then the intersection of BB prime with the optical axis is the optical center O. And we don't forget arrows on light ray. This is an incident ray and this is an emergent ray. Now we place the lens L perpendicular to the optical axis at the center. This is the lens L. Okay, I hope we didn't forget anything. This is it for part B. Now let's move to part 3. Now in part 3 they are telling me focal distance of L. A ray issued from B parallel to the optical axis meet the lens at point I. So trace with the justification the path of this ray. Then we need to trace and justify the path of a ray issued from B and parallel to the optical axis. This is the ray issued from B parallel to the optical axis. We don't forget arrows on light rays that indicate the direction of propagation of light. They are telling me it meets the lens at the point I. This is the point I. Now we need to complete the path of this ray. Okay, always incident parallel ray is related to the image focus. Here we don't know the image focus, however we know the image B prime of B. Therefore this ray will complete its path as if coming from B prime. So let's join B prime I. This ray will complete its path as if coming from B prime. Okay. Now let's do the justification. An incident ray issued from B parallel to the optical axis emerges as if coming from B prime. Now part B, they are telling me the emergent ray meets the optical axis in a particular point. So this is the emergent ray and this is the optical axis. This is the meeting point, which is the intersection point. What does this point represent of this lens? Okay, we know that an incident ray parallel to the optical axis is related to the image focus. Therefore, this point represents the image focus. Now let's do the justification. Okay, then the image focus which is in this case f prime is the intersection of the emergent ray with the optical axis. Now in part C they are telling me to deduce the focal length of L. Okay, so now after we have determined the position of the image focus, we can determine the focal length or deduce the focal length. Why deduce? Deduce means that we need to use the part just previously before, and in the part just previously before we have determined the position of the image focus, and now we can deduce the focal length from its definition, which is given by the focal length is the distance from the optical center to the image focus So from its definition, the focal length is the distance from the optical center O to the image focus f prime, and we don't forget the bar because this distance may be positive or negative. Now we count the number of divisions between OF and f prime. We have 1, 2, 3, 4, 5, 6, and we multiply by the scale along which we have counted the number of divisions, which is scale along the x-axis, and this will give me 6. Because the scale is in centimeter, then the value of f will be in centimeter. Always in physics, all quantities must have unit. And finally, it's a good habit to write our final answer in a box to make the task easier for the corrector. Notice our correct answer. Okay, so by this I have finished solving this exercise. I hope it was beneficial for you guys out there watching this video, and see you soon in another one.